All right, good morning or good afternoon, depending on when you're watching this, maybe good night even. We are going to jump into 5.4. So I'm going to share my screen with you. You have your notes out, obviously. And we're going to talk about solving special systems of linear equations. So just like when we solve regular equations, with just one variable, and we saw sometimes there was no solution or infinite number of solutions, or just one solution like a normal one. Same thing's going to happen here with systems. But let's go ahead and do the warm up here. So solve the equation for y. So it is in slope-intercept form. Go ahead and do that. Wow, that was quick. Yeah, all you had to do was subtract x from both sides, and then do the same thing on this next one. So first you subtracted 2x and then divided by -5. And you can change it to a decimal or leave it as 2/5. Okay, your goal, your learning target is that you will be able to understand that a system of linear equations can have no solution, infinitely many solutions, or a solution of one point, which obviously is what we call an ordered pair. All right, so you can just work with me on this one. You invest $450 for equipment to make skateboards. The materials for each skateboard cost $20. You sell each skateboard for $20. Okay, right. The cost and revenue equations, then copy and complete the table for your cost C and your revenue R. Okay, so $0, zero skateboards made, excuse me. What's your cost? $450. What's your revenue? You haven't done any, right? And as you can see, I don't know what happened there. That's weird. Let's see here. No. What number should go in there? We know it should be what? Yeah, 470, right? Because it's the initial 450 plus another 20 for the skateboard. And then our revenue, our money coming in, increases just by 20. Okay. B, will our company break even? What's the answer to that? No. And why? Well, why? Because your revenue never catches up to your cost, right? You're basically, after you spent the 450, you sunk the 450 into your business, you're spending $20 to make back $20. That's called breaking even. Okay, but it does not mean that we're actually making money in the company. Okay. You have a necklace and matching bracelet that have two types of beads. Okay, the necklace has 40 small beads and 6 large beads and weighs 10 grams. The bracelet has 20 small beads and 3 large beads and weighs 5 grams. The threads holding the beads have no significant weight, so pretend like they have 0 for their weight. A, write a system of linear equations that represents the situation. Okay, let x be the weight in grams of a small bead and y be the weight of a large bead. Okay, so don't we know that the weight of the small beads plus the weight of the large beads equals the total weight of the necklace, and then the same for the bracelet, right? So go ahead and write your equation based on this information and knowing that x is the weight of a small bead and y is the weight of a large bead. Okay, did you get 40x plus 6y equals 10? Right, 40 small, 6 large equals 10. And then for the bracelet, 20x plus 3y equals 5. Okay. Now go ahead and graph the system on the coordinate plane that's over there. Okay, so go ahead and graph those. You might notice something interesting. So go ahead and pause and graph. Okay, when you graphed, did you get the same line? Yes, you probably did, I hope, right? It's the same line. By the way, why didn't we go out of the first quadrant? In real life situation, we can't have a negative weight. So can we find the weight of each type of bead? Nope, right? It's just one line. We never see where they cross to figure out like an x coordinate, the y coordinate. All right, so that's that. So there's infinitely number of solutions, okay? All right. So based on that, what we're going to see is if we have two equations that have lines that cross and intersect at one point, that's the solution, right? Whatever that ordered pair is for that point right there. However, if we have lines that are parallel, do they ever intersect? No, no solution. Or like we saw in that last case, we could have a situation where basically two equations have the same line, in which case there's infinite number of solutions. So looking at this, no, one, or infinite. One, very good. Yes, it would be what, at 0, 2. This one, no solution. They're parallel, right? How do we know that? Well, think about it. If we put this one down here into slope-intercept form, we would add x to both sides, and it would be y equals x plus 1, and this one would be y equals x plus 2. It means the slope for both of them is 1, right? 1x. And different y-intercepts mean they never hit. And here, what about this one? They are the same line, so infinitely many. Notice if you multiplied, well, let's say we subtracted x from both sides, it would be negative x plus y equals 2, and then multiplied everything by 2, we would have the same equation here. Siren. Okay, so go ahead and solve this system of linear equations using all three methods. So substitution, elimination, and graphing. Okay, if you did this by substitution first, notice how y equals both of those. Doesn't that mean we basically could just set the 2x plus 1 equal to the 2x minus 5? Another way of thinking of that is taking, since y is equal to 2x plus 1, taking this 2x plus 1 and plugging it in for this y. And then when we solve, we get that. What? Is that true? No. So there's no solution. Again, you may have noticed that just by looking at this. Same slope, different y-intercepts, parallel lines. So if we had graphed, right, we would have gone on the first one to 0, 1, plotted a point. Slope is 2 over 1, so go up 2 and over 1, or how they did it, went over 1 and then up 2, either way. And from y equals 2x minus 5, they would have started here and gone over 1, up 2, or up 2 over 1. Okay. And if you did it by elimination, look what happens. If you subtract down, right, you don't just get one of the variables to disappear, both of them do, and the 6 equals 0. No. Okay. All right, so go ahead and solve these by the method. Well, you can use any method. Well, think about this. Why did I do it by substitution on here on the left? And then go ahead and use substitution. Hopefully you're thinking because this, I already have one of the variables that's easy to isolate, right? So I'm going to add 2x, and then I'm going to plug 2x plus 3 in for the y in the other equation. And you did this, so, which means what? Infinite number of solutions. Notice again, if you doubled everything in the top, if you multiply the entire top equation by 2, it would be this one. Okay, what about this one? Oh, do it by elimination. That's too bad, because it would have been nice to have done this by substitution, right? With y already isolated. But we're going to do it by elimination, which means we need to get everything lined up. So I added 10x and plus y equals 2. So now everything's lined up. Am I going to add or subtract? Subtract, right? Because they're matching. So we want to get them to disappear. But the problem is, both variables disappear. And 0 does not equal -8. So no solution. All right. Use any method you want. Go ahead and do them. I did substitution and then elimination. All right, I'm back. So it looks like I substituted or solved for the first x, or isolated the first x. So I subtracted y from both sides, plugged in the 3 minus y in for the second x. Remember, you have to go to the other equation. Distributed, combine like terms, and 6 equals 6. Oh, infinite solutions. Oh, I could have seen that right off the top just by multiplying this top one by 2 to everything. Would have been the same equation, which obviously means the same line. Okay, what about this one? You might be able to tell right off the bat here that these have different slopes, but maybe not. If they have different slopes, doesn't that mean they're going to intersect? Yes, it does. You could say one solution. So let's do it. So we're going to elimination. We're going to add or subtract. What do you think? X is matched, so we want to subtract to get them to go away, right? So I get negative y because it's y minus 2y. That's why I keep putting the parentheses in here. I think I mentioned that, but if I didn't, that's why. Just to make sure I know that I'm subtracting all of these. So 3 minus 4 is negative 1. Well, if negative y equals negative 1, y equals 1. And then what do I need to do to figure out x? Plug it in, plug it in. So I use the top equation, and obviously x equals 2. So my answer is 2 comma 1. And then we'd want to check, right? 2 plus 1 is 3. 2 plus 2 times 1 is 2. So 2 plus 2 is 4. Yay. Okay. The perimeter of a trapezoidal piece of land is 48 kilometers. Perimeter, remember, means distance around. The perimeter of the rectangular piece of land is 144 kilometers. Write and solve a system of equations to find the values of x and y. So what would your two equations be? For this one, you're literally just adding everything around, right? So that becomes 12y plus 6x equals 48. And for the bottom one, 36y plus 18x equals 144. Okay, and then we need to solve. I just did it by elimination, which means I need to do what to this top equation? I need to multiply it by 3 to get a match. Whatever you do to one side, you do the other. So then I have that, and those are exactly the same. So are we going to be able to figure this out? The answer is no. It's the same line, which means there's an infinite number of solutions, right? Okie dokie. Okay, what happens to the solution example 3 when the perimeter of the trapezoidal piece is 96? So same problem here, but instead of 48, it's 96. So go ahead and try that. And when you're done with that, start the video. Okay, so what we would see is then the slopes would be the same, but the y-intercepts would be different, which means the lines are parallel, so there'd be no solution. So how do we know that? Notice that they would have different, right? If this was 96, you would end up still having the 36y plus 18x when you multiply it by 3 to get a match. But then this number would not be 144. It would have been 96 times 3, which is what, 288. And then so we would have had a different y-intercept, which means that they would have been parallel, which means there would be no solution. Okay, exit ticket. Write a system of equations that has no solution. So think about what you need to have in order to make it so that there's no solution. You need to have parallel lines. What do parallel lines have to have? Same slope, different y-intercepts. So write one. Here's mine. Notice the slope would be, if I'd subtracted x, right, it'd be -1. Here I would subtract 2x and divide by 2. It would also be -1. The y-intercept here would be 2. The y-intercept here, when I divide everything by this 2, is going to be 6. They're different. Different y-intercepts, same slope, parallel lines, don't cross, no solution. Okay, for infinitely many solutions, I came up with x plus y equals 2 and 2x plus 2y equals 4. Notice if I multiply the top equation by 2, I get the same thing. So these two lines would have the same slope, right? Their slope would be -1 because I could subtract x, right? And the y-intercepts would be the same also, right? Because I would divide by 2, and 4 divided by 2 is 2, and that would match that one. So same slope, same y-intercepts means same line, which means there's an infinite number of solutions. All right, I believe that does it for 5.4, a quick little lesson. And now you'll be ready to take our first quiz after you do the BIM 5.4, and then we'll move on into the much more interesting and challenging second half. All right. I will see you guys later.